This lesson is on solving systems of equations by graphing. Before we start, I just want to clarify, a system of equations is when we have two different equations that we're going to graph together and find a solution. So you'll have two equations in slope-intercept form, like y equals 2x plus 1 and y equals negative 3x minus 2, and you'll have to find where they intersect. The point of intersection is the solution. And it will always be an ordered pair. So again, a system of equations is two equations graphed together. The solution is always an ordered pair that satisfies both equations. So when you plug the x value and the y value into the equations, it will work for both of those equations. If the line intersects at one point, then that point represents the solution. If the lines only intersect once, the system has one solution. If the lines intersect in all points, then they graph the same line and it will have infinite solutions. If the lines don't intersect at all and they're parallel, then there's no solution. So here we can see on the right, we've got examples of one solution. So these two lines only intersect at one point. So they have one solution. These lines under no solution don't intersect at all. So where they don't touch at all, there's no solution. And infinite solutions, they're actually both graphing the same line. And since they're the same line, they share all of their points. So there's infinite solutions. When we're solving by graphing, we just have to make sure that both equations are in slope-intercept form. Or y equals mx plus b. We're going to graph both equations. So you start with the y-intercept and use the slope to plot the next points. And then find where the lines intersect. And the point at which they intersect or touch each other is going to be the solution to the system. So looking at example 1, I have y equals 1/3 x minus 3. So I've got a slope of 1/3 and a y-intercept of negative 3. So I'm going to start by graphing that y-intercept, and then I'm going to go up 1 to the right 3, up 1 to the right 3. Now on the other side of the line, I have to do the opposite of the slope. So down 1, left 3. Now I'm going to graph the next line. I've got y equals negative 2x plus 4, so I've got a y-intercept of positive 4, so that's going to be at positive 4 on the y-axis, and a slope of negative 2 over 1, so down 2, right 1. And on the opposite side, I'm going to go up to left 1. And I know that this is where they touch, so that's going to be the solution. So the solution is 3, negative 2. So my x would equal 3, and my y would equal negative 2. Now we're going to look at example number 3 and example number 4. So example number 3, I'm going to graph, starting with the first one, y equals negative 3x plus 2. So I have a y-intercept of positive 2 and a slope of negative 3. So down 3, right 1. And on the opposite side, up 3, left 1. That next equation is negative 3x minus 4. So I have a y-intercept of negative 4. And I am going to go down 3, right 1. And on the opposite side, up 3, left 1. And here, I have parallel lines. So this has no solution. And I could have done this without even graphing the lines. So what you'll notice about parallel lines is that the slope is the same and the y-intercept is different. So if you look at two equations and you notice that you have the same slope for both of the equations but different y-intercepts, then you know they're going to be parallel, which means that they are going to have no solution. Looking at example number 4, I've got -1 as my y-intercept and +1/2 or up 1 to the right 2 as my slope. On the opposite side, I'm going to do the opposite, so down 1, left 2. And for the next equation, I have a y-intercept again of -1 and a slope of 3/6. So I'm going to come up 3 to the left, or to the right 6, or down 3 to the left 6. And what I'm noticing here is that they're plotting the same line, which means that they have infinite solutions. So they share all of their points. And I can kind of do something similar with this one that I did with the last one. So what I notice here is that the slopes are equivalent. So they're equal. They don't necessarily look the same, but they're equal. 1/2 and 3/6 are equivalent fractions, and the y-intercept is the same. So if you have the same slope and a different y-intercept, it's going to be parallel lines with no solution. If you have the same slope with the same y-intercept, it's going to be infinite solutions because it will graph the exact same line. So solving systems by graphing is relatively easy, but we can do it in the calculator as well. So in the calculator, you're going to put both equations in slope-intercept form. You're going to enter them into y equals, zoom 6, second trace 5, and then enter 3 times, and it will give you the point of intersection, and that would be the solution, but you need to know how to do it by hand as well.